Again, we will be proving another identity. So in this identity here, we notice we're adding two fractions. So the common thing we do when we're adding fractions is to do a common denominator. And basically your common denominator is this and this together. So I'm just gonna put a long line, 1 minus sine x in one bracket, and 1 plus sine x in the other bracket. The way I do common denominator, I just take this, divide it into here. The 1 minus sine x will cancel with the 1 minus sine x, so I'm left with 1 plus sine x, and that's exactly what I have to multiply to the top. Minus, I do the same thing, this divided by this, 1 plus sine x will cancel, and then I'm left with 1 minus sine x, so that's what I have to multiply to this top. Now, what I'm going to do is distribute this sign in here and this sign into there. So I'm going to end up with sine x plus sine squared x minus sine x. And that's a sign changer, so it becomes plus sine squared x. Here I'm going to FOIL this, and since it's the difference of squares, I'm just going to get 1 minus sine squared x when I FOIL. The middle stuff is going to cancel. Now, this will cancel because sine minus sine is gone. When I add these two here, I'm going to get 2 sine squared x all over 1 minus sine squared x is from this identity here. You'll realize it equals cos squared x. So 1 minus sine squared will equal cos squared. Now this part right here, as we know, sine over cos is tangent, and since it's sine squared over cos squared, then it will give you 2 tan squared x, which equals the right side. Just that. This is done. Thank you for watching again.